All right, reflection. Let's go over this. We're going to go over this a little bit differently. I'm just going to cover this first part, and then we're going to do the first problem, and then we're going to go into the second part, because the first problem is kind of unique in that it's not like the other ones. So, reflection. Most of you guys know that reflection is just where light bounces off some kind of surface. So let's talk about this first paragraph, and then we'll go into the first one. So, the angle a beam of light makes when it strikes the surface with respect to the normal. So first let's talk about what the normal is, right? So the normal is just the dotted line made just to kind of separate. It's a perpendicular line to the surface, meaning if the surface goes like this, perpendicular just means kind of like 90 to that angle up. Usually it's dotted though. I should have dotted. So this, in this case, is the normal, right? Okay, an imaginary line drawn perpendicular to the surface. Okay, when a light shines onto a mirror, the angle at which the light enters the mirror, which is the angle of incidence. So, right here, that's the angle of incidence. Just as an FYI, is exactly equal to the angle at which the light leaves the mirror. So we're at the angle of reflection, right? And this is called the law of reflection. Okay, so pretty standard stuff. In other words, the angle that it hits the mirror right here is going to be equal to the angle that it leaves the mirror right here, right? So let's flip the page and let's go to example 5, because like we said, example 5 is kind of unique, and then we can go back and do all this other stuff, right? So first, before we can read this, let's label some stuff. So this kid here, he looks at this mirror. First of all, this is a mirror, and this is a mirror, is what they said in the reading. So if he looks here, so Manish is in a house of mirrors with one of his friends. When he comes to the mirrors, situated at a 90-degree angle, which is here, these two mirrors, 90. Manish stands so that the light shining on his face is incident on one mirror at an angle of 50 degrees. So blah, 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 this is 50 degrees. They label it. What angle will the light reflect from the second mirror? That's this one up here, right? So first let's do some labeling, okay? So we know that if he hits it from this angle, then this here, the angle, this is his continuing gaze reflecting, right? This will be 50. And the next thing we're going to do, so if he looks here, this is also going to be 50, right? And because we know this is also a 90, we can just say that, hey, this is 40 degrees here. So that's pretty standard. So if we know this is 40 degrees at this angle, then right here, this should be 50 degrees. And let's go ahead and write the normal here. Our dotted line, right? Which means it hits the mirror at a 40-degree angle. And because this is 40 degrees here next to the normal, it's also going to be 40 degrees on this side. Okay? So it hits his first mirror at 50, and which means it's going to hit this second mirror at 40. So at what angle will the light reflect from the second mirror? 40 degrees. And it's going to be 40 degrees from the normal. So if you want to put that, that'd be good too. Okay, so this is the only one you're going to have like this, at least in this first few practice problems. So that's why I wanted to kind of do that a little bit different. So now let's go back to a little bit of explaining. So obviously reflection off of something flat, piece of cake, easy. You guys are already used to that. Now let's talk about reflection from different types of mirrors. So we have converging and diverging. Converging is just a concave mirror. It looks like a cave, right? You go in it, it's kind of like a bowl, right? Diverging, which is a convex mirror, which is kind of like a hill. Okay, so Just as an FYI. So let's see. Different mirror. Okay, so vocabulary. Let's go over this. You guys should have already done this in the vocab, but alas, we'll cover it anyways. Object distance. The distance from the mirror to the object. It has to be positive. You can't be negative. So the distance from the mirror to the actual object, it's going to be a positive number. Image distance. The distance from the mirror to the image. An image can be real, which means inverted and able to be projected on a screen, or virtual, which means right side up and not able to be projected on the screen. Okay, so just know that this is the image distance. And then we have the object distance. Focal point, the point where parallel rays meet or appear to meet after reflecting from a mirror. So the distance from the focal point to the mirror is called the focal length. So the focal point to the mirror is called the focal length. And the focal length on a converging mirror, so this is important, the focal length on a converging mirror has to be positive. So just so you know, that'll help you if you do one and maybe it's a converging mirror and you get a negative value, you're like, okay, maybe I did this wrong. While the focal length on a diverging mirror, what's a diverging mirror? It's this, right? Has to be negative. So keep this in mind. If you have a problem, they give you a number and they're like, hey, it's a converging mirror. So you can be like, okay, focal length, it has to be positive. Or, hey, it's a diverging mirror. Well, you know it has to be negative, right? Okay? So, mirror equation is this. Let's scoot that up. So it's 1 over the focal length equals 1 over the object distance plus 1 over the image distance. So just know the O stands for object, the I stands for image. Pretty easy, okay? So let's go ahead and do our second example, which just so happens to be example 6, okay? So, here we go. We got a bird. We got a bird looking at this globe, right? So, a popular lawn ornament in the 1960s was a colored reflecting sphere that sat in the yard as a decoration. Cool. If a bird is 10 centimeters from the blue reflecting sphere and sees the image reflected 5 centimeters from the blue reflecting sphere, what is the focal length of the spherical reflector? So first we need to do focal length. Okay? So first let's write our formula. 1 over the focal length equals 1 over the image distance remember that's an O, so the distance of the image, plus 1 over the object distance plus 1 over the image distance. Okay? Okay, so let's put our values in, because we don't really need to put them off to the side. You can, it's a good habit to, but for this one we're just more or less just plugging them in. Okay? So we know that the bird is 10 centimeters from the sphere, so that's going to be the object distance. So for that, it's going to be 1 over 10, right? Next, we know that the image is 10 centimeters behind the sphere, so that means it's going to be negative. So we're going to do plus 1 over a minus 5 equals the focal length. Oop. Okay, so let's think about something too. Remember when we talked about this? Notice the mirror type from the bird's point is convex. So what do we say about that? So let's go back here. We said that the focal length of a diverging mirror has to be negative. So what does that mean? That means that our focal length, our answer A, has to be negative. So we already know it's going to be a negative answer. Okay? So we're already there. So let's figure it out. Okay, so now we got to find our least common denominator. So with this right side, we can just multiply the whole thing by 2. So it's going to be 2 over 2, which doesn't change it, right? Because that's 1. So that's going to end up being negative 2 over 10, right? We just did that so we can combine these. That's all. So what we're going to have is we're going to have 1 over the focal point equals, because you're taking 1 and you're minusing 2, right? The denominator stays the same. So 1 minus 2 is negative 1, right? So 1 over the focal length equals negative 1 over 10. What we can do is just flip these both, because if you flip this side and you flip this side, so you're going to have focal length over 1 equals negative 10 over 1, which means our focal length just equals negative 10 centimeters, right? We don't really need to convert this to meters, not that important. If you wanted to, that's fine. You'll just have negative 0.1 meters, I think it is, so no big deal. Okay, so would the bird's image appear larger or smaller than the bird itself? So this one is going to be smaller, and that's that one. Piece of cake, right? The rest of these, like always, they're just going to give you a random, they're going to give you a different number, withhold a different number. So let's look at number 7. Polly applies her mascara while looking into a concave mirror. So the mirror is like this, right? Because it's concave. So if we think back what we said a second ago, concave mirror, or sorry, converging is what they're used to saying, will always have a positive value. So you know that your focal length should have a positive value. Now, depending on what they're asking for in the question, it could be positive or negative. So, let's look at this. In a concave mirror whose focal length is 18 centimeters. Awesome. So they give us the focal length, which makes sense that it's positive, right? So let's write our formula. 1 over the focal length equals 1 over the object distance plus 1 over the image distance. So our focal length is 18. It's going to be positive. Okay, so she looks at it from a distance of 12 centimeters. So that means her object distance, because that's her, she's 12 centimeters away. So we're going to go 1 over 12. How far is Polly's image? So the image distance is what we're trying to find. 1 over the image distance from the mirror. Okay, so again, piece of cake. First thing we got to do is we need to make it, because we know we have to minus this over, right? So what we're going to have to do is find the least common denominator between 12 and 18. So that is going to be 36. So if I multiply this by 3, that's going to give us 36 on the bottom. And the top's going to be 3, right? And this is multiplied by 2 will give us 36. And then the top's going to be 2. So we have, sorry, this is a positive actually. Oh, that's equal sign, I'm sorry. 3 over 36. 2 over 36 equals 3 over 36 plus 1 over that, right? Let's just rewrite it. 2 over 36 equals 3 over 36 plus 1 over the image distance. All right, so we got to get this over. So let's minus 3 over 36. Goodbye. Minus 3 over 36. Because we're just going to put it on the left. No big deal. So what we should end up with is negative 1 over 36 equals 1 over the image distance. So again, flip them because we can do that, no big deal. So we're going to have image distance over 1 equals negative 36 over 1. So our answer A is negative 36 centimeters. Piece of cake, right? Easy money. Centimeters. There we go. All right, let's look at B. Does it matter whether or not Polly's face is closer or further than the focal length? Okay, in this case, yes, it does matter. So, because more than one focal length away, and the image will start to be real and inverted. And you can actually see that, because I was looking just a second ago, I was kind of playing around with a concave and convex mirror. Well, this is kind of a bad way to look at it is. But if you are close I don't remember if you're close or far away. I think it's when you get too far away, you'll start flipping. Like your face will flip upside down, and then when you get close, it doesn't flip. So it's kind of interesting. So in this case, yes, and then explain it. If you get too far away, the image becomes real and it flips. Okay? All right, let's do number 8. Let's keep on going. A friend is wearing a pair of mirrored sunglasses whose convex surface has a focal length of 20 centimeters. So we have the focal length. So let's just straight up write our formula. 1 over focal length equals 1 over the object distance plus 1 over the image distance. Okay, so we have our focal length, 1 over 20. Okay, equals, if your face is 40 centimeters from the sunglasses, that's the object distance, 1 over 40. How far behind the sunglasses is your image? All right, so plus 1 over the image distance. All right, so we got to bring this over. Let's go ahead and switch this to 2 over 40 because now it's compatible with this one, right? So if I minus 1 over 40, minus 1 over 40, I'm going to rewrite it just so we can see it. So we have 2 over 40 minus 1 over 40 equals 1 over the image distance. So we have 1 over 40 equals 1 over the image distance. All right, there we go. So this one's a piece of cake. Flip them both like you guys have been doing. And 40 centimeters is our final answer. Cool. So hopefully you guys get the hang of this. It's not too bad. That's going to wrap up this part of, what is this, reflection? Yeah, I think it's reflection. Yeah. So if you guys got any questions, please let me know. Go back through, watch the video. If you guys want to watch other videos, that'll help. Awesome, go for it.